Will give you an overview of the NX Electrode Design application. Will give you an overview of the NX Electrode Design application. NX Electrode Design is a step-by-step solution that streamlines the modeling and design of electrodes for any tool project. In this demonstration, we will design, validate, and document electrodes for this core insert. The NX Electrode Design application can be found under the Start menu. Once we launch the application, notice how the Electrode Design toolbar is displayed. The process-based toolbar contains all the tools that you'll need to create and manage the electrode project, to identify manufacturing geometry, to design the blank and add the holder, to automate the creation of drawings, to validate the electrode design, to automate the bill of materials creation, to model the various sparking faces, and to calculate the burn area. So with that, let's get started. First of all, we will create an electrode project for this workpiece. Let's initialize the electrode project. An electrode project manages the associativity of electrodes to the workpiece. It contains machining setup instructions, and it enables the concurrent design of electrodes, allowing multiple electrode designers to work on the same project at the same time. To begin with, we'll specify the project path and the project name. By doing so, all components related to this project will be automatically named based on this numbering scheme. Once we've initialized the project, our next step will be to create a machining setup. The machining setup is a unique file that manages a specific workpiece and setup instructions. We'll have the flexibility to define any number of machining setups within a project. For demonstration purposes, we'll use one setup in this example. Next, we'll define the machining coordinate system for this setup. We'll use the face center option and define the coordinate system at the center of the bottom face. In the next step, the workpiece geometry is associatively linked to the setup. This enables the design updates to propagate effectively to the electrodes. With that, we've finished creating our electrode project with all the required definitions. The electrode project is managed as an assembly of files. The assembly structure makes it easy to navigate the project and make design changes. The machining of each workpiece typically consists of various manufacturing operations, electrode discharge machining or EDM being one type. The manufacturing geometry command enables the ability to specify various manufacturing operations to sets of faces. This helps automate downstream NC programming tasks. As you can see, manufacturing operations have already been specified for this workpiece. NX Electrode Design consists of powerful modeling tools for designing the electrode sparking area. Let's make use of the Trim Solid command to design the burn faces for an electrode. With some simple geometry selection, Trim Solid creates a solid representation of the electrode by searching for adjacent burn faces and automatically trimming the solid to the correct shape and size. Once the sparking faces are modeled, we can easily add the blank. The blank design command automates the selection and positioning of a blank, specification of standard holders, and provides options to key design parameters. We can define the blank material and define how the sparking head and blank are joined together. Let's define a blank by picking these two sparking area solids. As you can see, NX Electrode Design automatically selects the appropriate blank size based on predefined rules and positions it accordingly. Let's design a second electrode for this workpiece. In this case, you can see that it's necessary to adjust the size of the trim solid to enclose the entire sparking area. The Trim Solid dialog provides various options to achieve the desired shape and size of the electrodes. In this case, we'll change the size dynamically using drag handles. Once the sizing is complete, we can select the Intersect option to automatically specify the trimming faces. Our next step will be to define the blank. We'll pick the desired sparking head and define the blank. Take a closer look at the electrode we just designed. Notice how the electrode has been properly trimmed and reference lines indicating the top point of the electrode have been automatically created. Now let's validate that our electrodes have been designed correctly and that we don't have any interference issues. The Electrode Checking command provides various capabilities to detect, identify, and resolve design issues related to interferences with the workpiece. We also have the ability to capture and report burn area calculations for the optimization of the EDM machine. Let's pick these two electrodes to analyze this workpiece. Electrode Checking outputs a detailed report containing information about the touch or interference status, burn area, and manufacturing depth for each electrode. In this case, we only have a touching interference, which means the electrodes are designed correctly. The touch face area is indicated here. We also have tools to quickly identify the touching faces. Electrode drawings can also be created based on predefined templates. Let's create a drawing for this electrode. Electrode drawing templates can be pre-configured to report information in a standard format. Here you can see the electrode spark type information and electrode positioning information is automatically pulled into the drawing. Also notice how the title block is automatically populated. Standard electrode holders can also be predefined and reused in every electrode project. Let's add a holder to this electrode. A bill of materials for the electrode project can also be automatically created. Notice how the various electrode attributes are automatically captured and represented in the bill of materials.